if you look at your this week's packet, it's kind of a review. So it's not really like anything new lesson-wise. So this is all stuff that we've covered in the past 4 weeks. So I'm just going to go over a few of these things here. So just going over, there's about 37 questions. Actually, before that, I also want to point out that on the inside of the cover, it says rules for this packet. And there's 30 points for this packet. So it's like, it's a little bit different. Okay, so the whole packet is very different because there are 37 questions, but they max out at 30. So if you think about it, it's like there's 30 points and then possibly 7 extra credit, but they're not really extra credit because you can't really get them. So there are some strategies that you can use on this, and the first strategy would probably be something like if you're really, really certain, you can pick 30 questions and do those 30 questions, and you could probably get 100% on it. Or you could also do all of them and increase your chances in case you get some of them wrong. You would probably still max out at 30. So like in this example here, it says, if you answered 33 and you missed 5, your score would be 28 out of 30 or 93%. But if you also get, say, if you answered all 37 of them, but you got 31 correct, you would still get 30 out of 30 or 100%. And also just a reminder too, to answer all parts of each question. So I know sometimes people will usually answer, like in this case, like, well, I have some examples later. But if it says something like graph, you also have to graph it. And the rubric also still applies too. So if it says solve by substitution, then you better show substitution in the work. Okay, that's how you would get the full points in there. Let's see. Each page is listed for what attendance it'll be for. So one of the reasons I even thought about not doing a packet, because this is the last week before the quarter ends, and I wanted students to really focus more on getting in their packets 1 through 7 in. That way they can get the points, because those are the ones that I'm really looking for, the 1 through 7s. But this one was also another good one too, just to kind of go over, because there's only 30 problems. This is like, all the work is like 3 homeworks really. So this is not a very big packet. It shouldn't be particularly difficult or anything like that. It should be fairly straightforward. But again, I know some students don't check in with the attendance and they don't show up to the Zooms. So this packet is also for them as well. So if there's no packet, and students that didn't make it to the Zooms or didn't make it to like an email, because the email's been kind of going in and out all week. So this is their way of making up for it. So that's why I decided to go ahead and have a packet this last week anyway. So let's go ahead and look over some of these, and I'm not going to go over all of them, but I am going to go over just some of them. So let's see, find the domain and range of each relation and then determine if the relation is a function. So there's 2 things we have to find. So the first one is domain and range. So remember domain, which values those are, and then range is another set of those values. Function, so how to tell if something is a function, or so don't forget there's a rule on this one as well. So there's a way of telling if something is going to be a function or not. And that means, will you get a repeat on a certain number? So does a certain number repeat itself? Well, if it does, then it's not a function. Or if you're free of any repeats in this number category, then it will be a function. And then 3 and 4 are the same question, but this one is graphic. So we have a table, a map, and now we have graphs. So domain and range, I think when I'm looking at homeworks for these kind of problems, I'll usually get students that will say something like, well, it'll be -5, -4, -3, -2, -1, or something like that. Okay, but what about all the numbers between there? Because remember, this is continuous, meaning that if I had -1.5, I could get a value for that. I would get a value for -1.75. So there's literally an infinite number of numbers between here and there, which it looks like it begins here and ends there. So make sure you account for that in your domain and range. You would probably need an inequality or a between statement, and not just numbers, because we're not just naming numbers. It's not discrete, it's continuous. So again, it has a lot of numbers in between those 2 points. And there's a different, if you can see a graph, there's a different way of determining whether it's a function or not. So again, that's something that you would have to review. And with this, today, I'm kind of more just pointing people in the right direction, just sort of, you know, this is what you should be looking for, sort of thing, rather than going over it. I guess we could probably go over some of them, but we'll kind of go over the end, near the end. So let's see, use f of x, g of x, and h of x for these questions. So if you see them, plug them in, and remember, if it says something like g of -5, you would take -5 and replace it in the function g for all the values of x. And then you would evaluate it. So when it says find, it doesn't say the word evaluate, but when it has the word find the function, so this would be find the function g at -5. So yeah, you would plug it in and evaluate it, and you would probably get one number. I'm thinking for most of these, you're going to get one number, except for number 8. I think you might actually get kind of another equation. Let's see with this one here. Oh, and this one here, you're working backwards, so be careful with that one. And this one here, you're also working backwards as well. Ooh, okay, so there's a hint. So there's our 2 hints to look out for. All right, write each equation in standard form. So for numbers 11 and 12, you want to put them in standard form. So just a reminder, standard form, and I can write things on here, but I can't really keep it. So I was messing with this earlier today, so it's kind of learning how to use this as well. But there you go. So we'd have ax plus by, so that is standard form. But there's also some other things you got to be careful for in standard form. So like in this case here, you might want to just add x, or add 2/3 x to both sides. And it will be in this order, but there are some other considerations that you would have to account for if you were to put this into standard form. And that would be, standard form has a few other rules. For instance, x cannot be negative. So if you have a negative x, you're going to have to reverse the entire equation. X and y cannot be fractions or decimals. So if you get fractions or decimals, then you'd probably have to do something to change it. In this case here, I would have 2/3 x right here, and I'd have to do something to get rid of it. And you would also have no number, what we call greatest common factor, between all three, A, B, and C. So you'd have to kind of divide all of them by the same number if you can, until you can't divide any of them by any common numbers. So that's what we call a greatest common factor of 1. So those are 3 things you got to watch out for in standard form. Again, cannot be negative, cannot be fraction or decimal, and they have to be simplified with A, B, and C. And again, I can't, for this one here, I can't really go down, because if you see the equation, it's going to kind of go down with it. So I'm going to go ahead and erase that. All right, number 13 and 14, write each equation in slope-intercept form and then graph the line. So slope-intercept form, that's the main one that we've been using, the y equals mx plus b. And for the y equals mx plus b, you got to solve it. So you got to get that y by itself. So we got to get this y by itself, and then from there we'll be able to see the slope and the y-intercept, or again, the y equals mx plus b. And don't forget to begin your line with b, and then follow the slope. And I'm still seeing in some homeworks, not a whole lot, because I don't get a whole lot of homeworks back, but I think so far we've been really good about this. But in general, in most years, if I get work, I'm going to get a very simple thing that people do wrong, and that is they don't check the direction of the slope. So don't forget, a negative slope is going to go down from left to right, and a positive slope is going to go up from left to right. So it's a very simple thing, but people don't check the direction of the slope. So positive, negative, easiest thing, but it's also one of the things that cost the most number of points because people aren't looking out for them. All right, so give an example of a line that is parallel and a line that is perpendicular to each given line. So parallel here, and then perpendicular. So take this line, and remember, in order to be parallel, they would have to have matching slopes. That part's easy, but perpendicular is a tough one. And I think I'm gonna go over this one really quick. So I'm gonna make up a number. Let's say that we have an X value, a slope of, in fact, actually it'd probably be better to use the drawing tool for this one. So if I had like say 2 over 3 X, right? We take the 2 over 3, and there are two things we need to do to make a line that is perpendicular. The first thing we would have to do is, well, not really the first thing, but I guess one of the things, because you don't necessarily have to do it in this order, would be to make the fraction, if it is a fraction, into a reciprocal. Once it's in a reciprocal, you are also going to reverse the sign. So if it was positive, you're going to make it negative. And if it was negative, then you will make it positive. So this is going to be perpendicular to that now. So I plug it back in and make sure it works out. And if a number is not a fraction, then you will have to turn it into a fraction by putting a 1 underneath it. And then continue the steps. Reciprocal it, and then reverse the direction of the sign, to reverse the sign. All right, so again, that one's kind of a one that I know that a lot of people forget and mess up on, you know, and they'll usually do parallel and perpendicular with the same rules, you know, they'll just make both of them the same or whatever. So in this case, you have to kind of make your own line. All right, number 17 and 18. So find the X and Y intercepts of each line and then graph the line. So there's two things. We have to identify our X and Y intercepts. So make sure you answer the questions the way it should be. And I think it even says it here. So that was 1, 2, 3, 4, 5. The fifth paragraph on the rules of this packet says the questions must be fully answered in order to count. If the directions say to graph, then you must graph it as well. You must also show the work if you use a specific method. All parts of a question must be answered in order for that question to count full points. So in this case here, we'd also have to find the X and Y intercept. So I know some students will say, oh, look, this is already in slope intercept. I can just graph it, start from -3 and then go down 5 over 1, and then I graphed it, I'm done. But the directions also say you must find the X and Y intercepts. So don't be skipping problems just because you feel like you know how to do them. So again, all points must be, all answers must be, all questions must be addressed. All right, so to find the X axis, you would make Y equal to 0. So they take turns being 0. So once Y is equal to 0, then you would solve this for X. And then you would do the same thing for Y. So make X equal to 0, and then solve your equation for Y, and that should be your X intercept. Where X and Y are those intercepts, you're just going to go ahead and, you know, I just noticed that this thing has a typo. It's not my assignment, but I noticed that I noticed now that it doesn't have a C. There should be a C right here. But anyway, yeah, you would put the line through both of those points. And then the same for this one as well. I don't think either of these are particularly tricky, but you never know. All right, moving on. So we got 37 to cover, so we're about halfway done. Write an equation in slope-intercept form with the given information. So again, we have to make a line that passes through -8, 3 and has a slope of -2. So this one's a pretty easy one to do, and I can't really write it out exactly, but you would use point slope form. And the point slope form is the one that looks like this. I can't write the little numbers, but there should be like a little number 1 here and another little number 1 here. So it looks something like that, but it'd be 1 instead of comma. You would take these ordered pairs, so x is -8 and y is 3, plug it in, and plug in a slope of -2. So actually this would be m. Oops, I can't fix it. That would be m right here. This first x would be m, so you'd plug in -2 for that. The other one would be also kind of tricky as well. For this one, you would use the same thing, but you would also have one more step to take care of. And that would be something like this. You would have to use that slope form, because in this case, it doesn't give us a slope. It just gives us 2 points. So you would use your point slope form. I'm sorry, what do they call this thing? It's just the slope form, the slope formula. Oh, I guess that is what it's called. Anyway, so it looks something like that. You would plug in these 2 points, get your slope, and then use the same point slope form to get the other one. Okay, so with these ones here, let's see, I might give you 1 or 2 to help you set up for these ones here. And this page here is one of the reasons why I could remove these questions so that there's only 30 questions, but I could also anticipate some students, already could figure this out and would easily be able to get these problems. So, yeah, so you do have a choice to skip some of them, but if you skip too many, it's going to go below 30 or something. But this should be an easy assignment to get 30 points on. Especially if, just give it a shot. You never know. Give it a good shot, a good attempt to see if you could actually get these. But anyway, I guess since you're here, I'll go ahead and kind of help you start up on this one here. So for commission as a realtor, that is a person who sells houses, Michelle earns $349 plus 3% of the purchase price for each home she helps buy or sell. If she earned $8,965 in commission on a certain home, find its purchase price. So just a quick review, purchase price is the amount that the item costs. So before any taxes or fees, usually that's how much the store or an ad would say. So like if you go to a store, does this have anything on it? No, there's no price tag. Let's see. Oh, here's one. So I went to the supermarket the other day and I bought some peanuts. I think it said something like $3.99 or $4.99, but that's not how much I paid for it. I probably paid something more like $4.16 or something like that. I paid a couple of pennies over the dollar amount. That's because of taxes. So again, purchase price is what they tell you it's worth, not how much you actually paid for it. And then commission is what we call take-home pay. So in this case here, we would think of which equation we would need. So in this case, there are 2 elements. There is a fixed price and a variable price. So this kind of tells us that there's actually 2 things going on, fixed price and variable price. So we would need a slope intercept form. And it would go something like this. Commission is equal to, and it mentions $349 first, but if we want to keep it in the, and I'm not going to mark you wrong if you put it first, because you could put $349 plus 3% the way it was written in the problem, and I probably would still accept it. But if I want to make it look like y equals mx plus b, it would look something more like this. So in this case here, I'm going to substitute x for p, which is purchase price. So that's again the beginning cost. So you're used to paying taxes if you buy things at any store for most items. So if you buy something, that is gonna, you're gonna add that cost back on to the price. All right, so this should work out. So the take-home pay, the commission, equals 3% of the purchase price plus $349. Now here it says she earned 8,965 in commission. So we know that this is, oops. There we go. So it looks something like that. Now this here, it says find the purchase price. So we know that's the part that's missing. That's what we don't know. So we're able to leave that one as P and then solve this one. And you should get a bigger number. And with any word problems, you should, again, give it the sniff test. Just as an example, let's say that we solved this problem out and we got something like $20,000 was the price of the house. Does that seem very likely? No, $20,000 is like low, okay? If you got something like 2,000, you know, that's like the sheds at Home Depot. So yeah, that's not very likely. So just to give you an idea, and the price of houses can vary greatly, but a typical house, you know, medium-sized house in most neighborhoods in America are going to be somewhere between 50,000 to about 200,000, and they can be a little bit higher. So if we got something like, let's say we were working on this problem and we got something like 500,000, that better be like a beach house. And well, actually beach houses would be like millions or so. I don't know, housing market's weird. But anyway, we'd have to kind of find something that is reasonable. And like I said, it'd be like 50,000 to 250,000. And let's go ahead and look at this next one here. Well, we got this one here. This one is a bit of a different question because it says, on Ryan's last social studies test, there were two types of questions, true and false questions worth 20 points each, and multiple choice questions worth 4 points each. If Ryan earned 86 points on the test and he knows he answered 18 multiple choice questions correctly, how many true false questions did he answer correctly? So this one he's probably thinking, you know, afterwards on the test, you know, how did I do on those questions? Because, you know, true falses are always really tough. Like they should be easy, but, you know, like I've taken multiple choice tests and they're always like, does this person do not, will, does, undo this? And it's like, what the heck? So sometimes it's like, it should be really straightforward, you know, like, did the person do this? But instead they add a whole bunch of counter examples and negative statements. And it's like, all right, so again, that's just my experience. So let's go ahead and look at these two types of questions. So there's two types of questions. So in this case here, we're dealing with two factors, two inputs. So we could have, like in this case, X be the true false questions, and the multiple choice questions would be the Y value. So again, there are two inputs. And in this case here, he knows he got 86 of them. Now this equation is not entirely set up, but again, this is more just to help how to get started on some of these problems. And again, this is a review. So, you know, still try your best on getting as many of these as you can, but I know some of these are gonna be like these two, you know, it's kind of hard to start off on them because you're like, I think that still is the big thing. And I had some students this morning asking me about, you know, how to set up word problems and stuff. And I know that is one of the big things that happens is setting them up, because that's usually the hard part, is getting started. Just like anything in life, okay? You know, it's like working a job is probably not that hard, but finding a job is the hard part. Getting motivated to turn in applications, go to interviews, and do all this stuff. Now for number 23, I changed this example. So it's a little bit different from what you see here to what is in your packet. So this is another example of one that you may just have to try your best on. But we have done one example of this. It was the one with water and temperature. So it gave you something like water and temperature, something like the deeper down you go, you know, they took the temperature at several feet below the surface of the water, and then the temperature goes down. So this one is very much the same way. You're dealing with much bigger numbers here though, but it would be the same type of example. And yours is not telling you to use linear regression. Now this line, if I had to guess, is not going to be a perfect match. Okay, so it's, you know, a plane doesn't just perfectly go down at at a constant speed, a lot of times they're going to do a lot of arcs and curves and stuff. So this example may not match exactly the table. The model won't match the table. But again, as long as you get something that's like within 1,000 feet or something, I'll probably still accept it. So to write an equation, you would use your slope model, the y2 minus y1 over x2 minus x1. Get your slope, plug it into either of your formulas, your point slope or something like that. And then you will get a rough formula for how this plane, as it's going, looks like it's going down, how much it goes down in minutes. So x is the number of minutes. And in this case here, it says, where is the plane in 8 minutes, after 8 minutes? So for this one here, you would, well, it doesn't have 8, and there's a reason for that, because you're supposed to kind of plug in x as 8, and that should give you the height. So you're using the formula you got in part A to get this part here. And then for C is how long will it take the plane to land? Now, for this one, actually, I'm gonna kind of tell you, because altitude is the y value, and you would substitute in 0 for that. And once the altitude is 0, you know the plane is on the ground, it's landed. And in that case, if you were to kind of solve it backwards like that, that'll tell you the time that it took for the plane to land. And again, a pretty tough example, but again, you don't need to do all of them. This is one of those questions I'm guessing you're going to be skipped. But you get mad respect from me if you do this problem, because it is pretty tough, and you're basically answering 3 questions, and it's still only worth 1 point. All right, now we're getting into some of the area that we've already kind of covered. So this one here we covered within like the past week, so this should hopefully be fresh in your mind. Solve by graphing. Now for this one, I would recommend that you put them into the y equals mx plus b, and then use that. So again, look for the b, which is the begin, follow the slope, and really you got to do your best on graphing these, because if your line is slightly curved, slightly in the off direction, you're probably going to get a number next to it rather than the number you're looking for. And again, make sure your lines go all the way across, and that goes for all linear graphing. Make sure your lines go from everything you can see on that line. So again, from edge to edge. And then look for the area where they cross. That area where they cross is going to be the point where you can plug in x and y, and both equations will be true. Both of them will come out balanced. So that would be a solution for both of them. So again, you're looking for a solution that works in both of these equations. All right, hopefully I didn't miss anything on explaining that one. Solve by substitution. So again, this one here, the directions are important. So you have to use substitution. You could probably do this using elimination, but then, looking at the work, you got to show your work, and it's got to show that you substituted. So maybe to help you out on this one, I could probably do a little bit, to nudge you in the right direction. And that would be, well, I can see that x is already by itself. And if x is already by itself, that means it would be very easy to solve for it. So I'd minus 7y. So on this side, I would get -6 minus 7y equals x. Take this -6 minus 7y and plug it in for this. You should have 2 y's, but distribute it out, multiply it, and then you should be able to get the y. Once you get the y and you know what it is, take that and plug it back into one of your original equations, or even one of your modified equations if it's easier that way. And then you will get your x and y value. And that's a little bit different than the elimination method. For the elimination method, first step is to make sure that they line up, right? You got to have your x on top of the x, which in this case, we're good to go. But the y is not on top of the y. In fact, the y is over here. So I don't know how often this happens, but I think I've seen it a few times, and that is students just going ahead and trying to eliminate these two, even though they're not exactly the same thing. In fact, they're not at all the same thing. So first thing you'd have to do is put them in the same order. So both equations have to be in the same order. And once you would have them in the same order, so you'd have 14 and -7, which is very easy to get them to match because I could multiply this bottom one by 2 and I would have -14y. So I'd have 14y, -14y, put them together, you got 0y, and you eliminate the y. And that'll help you solve the x. Get the x, plug it back in, get the y. Whew, okay, but again, I'm hoping I don't have to go over as much on that one because that's something we covered very recently. And here's another word problem, and this one would be, and again, there's sort of a hint because this was a system of equations. So that would mean that you would need a system of equations for this one. So you would need 2 equations. And maybe to kind of help you start out on this one too. So you have the worth, right? So it'd be like 0.25x plus 0.05y equals this number. And then for the number of nickels is 5 less than twice the number of quarters, you'd probably have to come up with something to make that one work. And that one would actually be kind of tough. Maybe I'll go ahead and, since I'm here, I'll see what I can do on that one. So this is only for the second equation, because again, you will need the first one, but that one should be pretty easy. This is like the 5th or 6th time we're dealing with nickels and quarters. So let's see. Number of nickels. So you would have x is, okay, so it mentions quarters first, so nickels would be y. So y is 5 less than twice the number of quarters. And remember, when you see the word less than, that means you're subtracting 5 from the number you just got. So the number of nickels is 5 less than twice the number of quarters. So take the number of quarters, double it, then lessen it by 5, and then you will have the number of nickels. So some of these you do have to look over and think, okay, wait, did I set this up right? And in this case, actually, it would be pretty easy because we already have this solved for y, so you could easily plug it into your first equation, which we have not covered here. So anyway, but yeah, that one looks like that one actually kind of looks like it would be an easy one. Once you have that second one, this one also looks like a similar problem. 3 systems of equations. I think we actually covered that one in the very last lesson, so that one should be hopefully good to go. But if not, that's okay. There's always tutoring tomorrow, so give these a shot if you want to. You know, go through as many as you can. Oh, and don't focus on this one either. Okay, so I don't remember if I went over it in this class, but the reason this is a review, there's no new lessons. Okay, this packet is not actually due. What does it say? It's due until the end of March, so 3/29. So if you don't get it, don't focus on it. I want you to focus on packets 1 through 7. Okay, as many of those as you can. This is in case you finish all of these. Okay, so again, quarter 3 grades will only include packets 1 through 7. And this one is 9, so it will not include this week or last week. So do this one if you have time, but again, don't focus on it until you finish the other ones. But it's also here just mainly to count attendance and just to wrap up the week. I didn't want to have new lessons right before spring break, so that way we'd have people, getting lost between what just happened and stuff like that. So I thought this would be one of the best ways of doing this. All right, so let's go ahead and keep going through this. And for this one here, you'd graph it. Make sure you use the dashed line or the solid line, because remember that is part of how you show the solution areas. Is will there be a dashed line or a solid line? And remember that counts on what type of inequalities you have in there. And then from here, after you make your dashed or solid line, you would shade either the top or the bottom of each of these. And in this case, it looks like you only have one line on this one here. So it's, again, either going to be the top or the bottom. For 35 and 36, you're going to have 2 lines, and each of them are going to have a top and bottom. or as I like to put the little arrows on each side of the graph, and that tells you which area, because in this case, you could shade both of them kind of lightly, and then where they overlap, that would be the area you make it much darker. Or you can use the little arrow method that I like, and you only shade one area. That way, you know where any point in that area would make both of these inequalities true. They would have the mouth open towards the bigger number. And also, if you make a mistake, it's much easier to erase just one shaded area than two shaded areas. And let's see, same thing with this one here. You'd have, it looks like there'd be two lines, and then fill it in. And that's it for this one here. So again, there's 37 questions. You only need to answer 30 of them. And this is mostly a review. So these are all things that we've kind of already covered before. So that way you're not stressing out about anything, and let's just kind of wind this down and get ready for the spring break, because this is the end of the chapter, chapter 2, and we'll start chapter 3 on when we come back, which would be, let me give you the 22. So on the 22, then, we'll be headed back to classes. And the situation might be a little bit different, just a heads up. They are talking about bringing students back into the school. I think we're still hammering out some of the details, so I don't want to say anything too much. I don't want to say it's going to be this way, and then when the official statement comes out, it's going to be a different way, because then people are going to feel like I lied to them. So I'm going to wait for the boss people to tell you what's going on. So, but that's all I know about that so far. So again, fourth quarter, things might change. We might have some people in the classrooms and that sort of thing. So I don't know if you have any questions, because we could maybe go over like a few of these. How am I doing on time? Maybe like, maybe 3 of them, I say, maybe. So if you want to go over one, you can, or 2 or 3, we can. If not, that's all right too. I think that's pretty much all I have for today as well. If not, that's okay, because we still have tomorrow. Friday is our regular tutoring day. So again, don't forget, that is one of the resources you have. In fact, I might send an email out to everybody reminding them that you also have Schoology, you have the YouTube channel, you have, what did I just say? You have tutoring, right? There are things to help people, because I know some people were saying that their grades are bad and they don't know what to do, but it's like, if they don't go to tutoring, I can't help them. But again, hopefully if we have some people in the classroom, I don't know if that's going to help, or I don't know if they're going to be in the classroom. I think we also said that they might just all go to the gym and kind of have spaced desks, and they can use the internet and stuff like that. Like I said, we haven't really hammered out all the details yet, so it's going to be tricky. Oopsie. So I think you got all of these. I think you probably would be able to get all of these without much. So I guess we could probably kind of stop here. And that might be it for today. So again, I just wanted to cover this packet, maybe go over a few of them, and that was pretty much all I wanted to do, because we didn't really have a lesson this packet. Last lesson, we only covered something that we already covered. So this is, again, kind of a review week. This would also be a great time to have a test too, but I don't know if everyone would be ready for it. But anyway, yeah, I guess that's it for today then.